Good morning, good afternoon, and welcome to the VMware Data Solutions Industry Series Talk, where this is the second session focused on retail analytics with improved customer experience using VMware data. And I would like to bring in three very snazzy gentlemen to the stage. You can see them on your screens to the right and on your screens in front of you. We have Howard Twine, Michael Wright, and Gregory Green. Thank you guys for joining us today. But before we get started, we do have a few housekeeping items that we'd like to cover. First, we'd like to encourage any and all questions. So if you have anything to ask us, please ask us using the Ask Your Questions tab. These gentlemen here that you see will love to answer them live throughout today's presentation. And in addition, we know that you guys are here to hear from us, but we'd love to hear from you. So if you have any comments, any feedback, anything that you'd like to see in future webinars, leave us feedback using the Rate This tab. And we do take that into consideration when planning our webinar schedule. Now, without further ado, let's hand this off to today's speakers.
Thanks very much, AJ. I'm Howard Twine. I work within the RabbitMQ product team here at VMware. Myself and my colleagues are responsible for not only the many different commercial offerings, but also we work closely with the open source community for RabbitMQ. We work closely with a bunch of very talented engineers. Myself and my colleagues manage the product roadmaps, marketing collateral, and very much more. Mike.
Hi, my name is Mike Wright. I am a solutions architect in the Edge business unit within VMware. I focus on helping our customers put solutions together that involve Edge profile devices of all sorts of shapes and sizes and build custom apps, computer vision, AI applications to be distributed across a wide variety of locations. Happy to be here. Look forward to the discussion.
And hello, everyone. My name is Gregory Green. I am a solution engineer with the pre-sales team. I focus on the data side, supporting data services to support application development using our VMware products.
Excellent. Right. Well, thank you guys for the intros. Let's get stuck in here. Just to run through the agenda here, I'm just going to run through a bit of an introduction around this webinar, some of the topics we're going to cover, and then sort of set the scene. And then Mike's going to cover some aspects of computer vision at the edge and how that can be used for real-time analytics. And then with Greg, he's going to cover the sort of loyalty promotion aspects of things in this webinar as well. And then we'll have a wrap up and time for Q&A at the end. So once again, thanks everybody for taking the time to watch this session. Last time out, we talked about the supply chain challenges in retail and how VMware data solutions like RabbitMQ, Gemfire, and Greenplum can be deployed to improve business operations efficiency. This time, we're going to cover some of the marketing aspects for brick and mortar retailers. We're looking into two key areas that can greatly improve the performance of a retail business, that of analytics from an in-store perspective, and the other being improving the in-store experience for visitors. So what do we mean by retail analytics? Well, typically store owners will use different data sets to monitor inventory levels, supply chain movement, consumer demand and sales in store. However, this kind of data is traditionally collected offline and has not really been available for stores in real time. In this webinar, we're going to take a closer look at how computer vision or artificial intelligence applications could be used to provide consumer behavior analytics data sort of in real time. And obviously, that's a subset of the larger discipline of retail analytics. We're also going to discuss the challenges of deploying apps like this at scale across multiple branches in different regions, as well as some insights into how VMware solutions can be used to develop these types of applications. Now, one of the questions I certainly asked myself when we were planning this is, why are consumer analytics important to retailers? And I mean, it's fairly obvious that as operational costs increase, profit margins are constantly being squeezed. And it's become vital for retailers to make the best use of every single square inch of retail space available to them. They're keen to improve the relationship between store visitors and the store itself. And with better insight from analytics, they can improve that overall experience. But once you've got this analytics data, what can you do with it? And of course, one foundation of this, using this data, is the loyalty program. Now, that's nothing new. In fact, Betty Crocker was one of the first to introduce box top tokens as early as 1929. But with online retailers getting more and more sophisticated with access to more and more consumer data, there's always been a challenge for brick and mortar retailers to try and emulate part of that online shopping experience in store. And to sort of put that in context, 80% of Netflix views come from their own recommendation service. So how could you recreate that kind of recommendation service in store? And we'll take a look at how that could possibly work in practice a little bit later on in this webinar. So taking a look at the analytics side of things, how could retailers better understand consumer behavior in store? And store operators want to know if they've got the right products in the right place in store and at the right time as well, in order to maximize sales. Obviously, this is easy for online retailers, and consumer browsing profiles are nothing new at all. But for brick and mortar retailers, the old school approach and the traditional approach is to upload sales reports on a daily, weekly, or monthly basis back to a corporate data center where that data would be processed. Obviously, taking that approach, any kind of trend analysis from this offline data can be out of date very quickly, and stores could miss rapidly growing trends. Any data that's gathered in store has got to be accurate, it's got to be reliable and up to date in order for it to be useful to other parts of the business. So just thinking about the data capture process, consumer insight is a real challenge in store. Of course, retailers know exactly which products people buy through loyalty programs and point of sale data. But what about the journey before they make those purchases? For those stores that have in-house barcode readers for shoppers, you could track the location of those scanners using in-store sensors. But not all customers use them, and it wouldn't show browsing behavior before purchase. So how can a retailer better understand the influences on a customer while they're visiting the store? And how could a store owner monitor the performance of certain product layouts on shelves? You could, of course, fill all of the aisles in the store with cameras and streamline video data to perhaps a cloud-hosted analytics service. And with AI, you could generate some useful data about customer interaction with the products. But that's likely to be a heck of a lot of data that you've got to get from the store up to that cloud hosted service. If you had 3 cameras per aisle and 60 aisles in a typical store, that's 180 streams of video data from one store, and only for analytics. And how do you transport all of that into a cloud hosted service? Well, this is where the edge compute comes to the rescue. If you were to deploy a small footprint hardware appliance in store with several video feeds attached to it, and host a computer vision or AI application on that same hardware, you could establish which products consumers are interacting with and for how long. Once processed, only the metadata that's generated as a result of that would be sent back to your cloud analytics service. And this can be easily done using RabbitMQ streams, for example. And streams provide not only the bandwidth to send significant amounts of metadata, but they also provide resilience in that data. As well, RabbitMQ is highly scalable, making it equally well suited for this kind of application. And later on in this webinar, Mike will show how VMware's Edge Services platform can help solve many of the challenges for this kind of solution. We'll discuss the importance of iterating on a design, a concept, or code development, and the challenges with computer vision that exist, such as the vast variance in external data points, and the need to iterate is becoming ever more vital. So once again, once we've got this data, what do we do with it? And retailers would love to copy and paste the online shopping experience in store, but that's just not realistic. You could use in-store apps and devices, but with in-store barcode scanners and retailers' own shop and scan type applications for mobile phones, it is possible to link analytical data back to individual customers through loyalty or rewards programs. The same applies to other in-store devices like smart mirrors, for example. Using these devices, it's possible to send customized promotions to specific customers at key points in store. And using solutions like RabbitMQ alongside other VMware data solutions offerings, as we've seen that in previous webinars, today Greg will show how these applications can be used hand in hand. RabbitMQ in particular is useful for this type of application because it supports different protocols, especially for IoT type devices where a protocol like MQTT may be more prevalent. RabbitMQ can also be used to verify promotional messages against existing inventory in store. Nobody wants to arrive in store with a mobile phone app, get a discount voucher, only to find that actually the store hasn't got stock of that particular product. So timing is crucial with a design like this, with a system like this. And there are challenges to this to make sure that the customer gets notifications at the right time. And again, nobody wants to get a discount voucher for a product after they've actually bought it. But equally so, retailers need to have confidence in the system that's being developed to provide these promotions to ensure that only one voucher is sent to the customer at the right time. Although a customer might be delighted to receive 100 $5 discount vouchers, you do that more than once, it doesn't make for a sound business model. So it's got to be robust. So how do you ensure that vouchers are sent to many thousands of devices only once at the same time? How do you ensure that any solution like this is properly scalable? And later in the webinar, we'll hear about the importance to leverage and manage your analytics database and not overstress the code, the code around the database, that is. And we're also going to take a look at the dreaded vendor lock-in, especially for cloud-hosted solutions. Is multi-cloud really a thing here? Well, in fact, it's more than likely with a solution like this, with its many moving parts, that more than one component will be hosted on a completely different cloud provider platform. And in that particular case, what part does Kubernetes play in solving this kind of problem? And if notifications are so time critical, especially for in-store promotions, how well does event streaming from RabbitMQ play in a Kubernetes environment? And Greg's going to take a closer look at this later on in the webinar. So with that, I'll hand over to Mike for his computer vision demo.
Okay, thank you, Howard. So once again, Howard teed up the topic of computer vision at the edge. I'm going to jump a little bit deeper into this area and also do a bit of demo and walk you through how did I put all this together as maybe a framework you can use for building your own computer vision use cases from retail store locations, distribution centers, wherever some physical location may be that you think there might be valuable insights you can gain from each of those sites visually, and send that back, potentially to a central data center and perform your aggregate analytics. And that's kind of what Greg's piece is going to pick up on. But I wanted to walk you through a demo after I go through a couple slides here. So in retail, computer vision is probably one of the hottest topics for having an edge infrastructure at each location. There are other reasons like disconnected networks and high latency for people to perform certain transactions at the store. But in terms of modernization, computer vision is one of the hottest use cases driving for modernization at the store. And I don't need to go through all these in this diagram here, this graphic. But as you can imagine, seeing what's going on at different places within a retail experience, or what store operations folks are doing in terms of stock keeping and safety and quality control, the use cases are limitless in terms of what you can do with computer vision and apply some inferencing. And so, like Howard also said, is that it doesn't make sense that if you're gonna try to capture a video input and respond to what's being done as part of an AI algorithm, it's quite expensive to ship all that data to the cloud. So how can you do this? What frameworks are out there that you can use to build this yourself? If you've decided, hey, there's third-party COTS vendors that put this all together, I might be able to do that, but you might be a sort of retailer that says, you know what, we have such a unique use case, we need our developers to build this ourselves. So I'm going to walk you through how you could maybe apply a framework to address any one of these use cases you might see on this slide here, or any others that you can think of. So I'm going to do a demo here first before I walk you through how did I do it. And I'm going to step up. I'm going to change the layout of the screen here. I think I should be able to do, well, it's split now. Let me share my screen, and the guys on the phone will tell me whether this is showing up correctly or not. Share. Okay, and I'm going to open up two views here. I'm just going to monitor a queue that I have with RabbitMQ, which is going to be capturing inferencing results that are happening at my store on my edge device. So I am attached to a Kubernetes instance running on a very small device that's over my shoulder. Hopefully, AJ confirm whether you can see both the screen share and my video display. I might have to toggle back and forth between the two. But right now, I've started up a log stream from a pod that's running Kubernetes at the edge. And what I'm going to do is I'm going to pick up my camera. My camera is just simply a USB camera attached to an Intel NUC. And so this is probably the more economical version of edge that we see, with retailers. Sometimes the whole process may be. Whoops, let me screen that again. Sometimes the whole process may be done with more expensive, larger installations of edge footprints. Of course, VMware supports doing those sorts of things as well. But in this case, I'm going after the economical approach for doing inferencing at the edge. So right now, I'm going to I'm panning around with my camera, and I've got some Legos sitting on my desk. Those are the retail items. And you can see it's identifying the X-Wing. It's going to identify a Razor Crest potentially. And so this gives me a way to visually see items that might be carried by customers, might be something that somebody's checking out in a checkout lane, just simply by using a USB camera and a small Intel NUC and doing inferencing on those devices at the physical location. So this alleviates the need for me to ship all that data from the camera to cloud and only capture the inferencing results and send that back to cloud with the help of RabbitMQ. So I'm going to get back to my desk here and walk you through how did I put this together. So like I said, it was I've got an Intel NUC that I'm deployed to. And just to quickly go through the pieces in this, I will zoom through my flow here, and then I'll walk through a little bit of this interactively. So what I did is I started out with, there's different frameworks. Like Intel has a framework called OpenVINO. That's for using accelerated graphics cards that are built into a thing like a NUC. Intel has GPUs built into those. There's also NVIDIA DeepStream that you can use for the more expensive edge infrastructure where you might have an NVIDIA GPU deployed to it. So OpenVINO and DeepStream are very similar frameworks. But before you even use those frameworks, you've got to create a model. And there's oodles, tons of pre-trained models from both NVIDIA, from Intel, and also from Google with TensorFlow. And so what I wanted to do is I wanted to start with TensorFlow to build the model, train the model, and then convert that to an optimized copy of that model using OpenVINO. So the process starts with, I want to, as a developer, I want to train my own model. So I start with capturing video samples, splitting that up into frame samples, and then the labeling. So there's many tools out there that you can use to label your sample frames so that you can identify the objects in the frame. And then using TensorFlow, I grabbed a copy of their pre-trained model, and what I did is I fed it with my sample data and modified the results of the model. And so TensorFlow has tons of, Google TensorFlow has tons of pre-trained models that you can start with. And it's a fairly easy process to feed it, your labels and your sample frames. And from that, I generate an output model that's use what's called the single shot detector method of object detection. And it's the neural network that I'm using is MobileNet. And I'm not going to walk through that whole process of training the model because it takes a good chunk of time to wait for those models to be produced. But then I want to build an inferencing app using Python, and I want to do this in a very DevOps way. As a developer, I want to simply care about building Python code that uses the inferencing model and iterate over refining that over time, and have just a DevOps mechanism already built to create my container and deploy it to Kubernetes for me. So what I do is I have a GitHub repo, and this is a public repo that I can share, where I'm committing my code written in Python using the OpenVINO framework from Intel. When I commit that code, it's going to kick off a process that is done with the help of another VMware product called Tanzu Application Platform. Tanzu Application Platform automates the entire software supply chain for you. So when I commit code to my GitHub repo, that's going to kick off a process that, if I zoom in here, and make it see it better, it's going to do all these things. It's going to trigger a CI/CD test pipeline using Tekton. It's going to do it's going to code scan my code, find out any vulnerabilities in the code base itself. Using cloud native build packs, it's going to build a container from that code automatically without Docker files. Now, I created a custom, what they call cluster stack, so that it would support the utilization of a USB camera and a GPU from inside a container. There's some specific things that you have to do to the container to allow that to happen. But Tanzu Application Platform automated the creation of the container for me. Then once again, I scan the resulting container, I look for vulnerabilities there, and then I publish to my image repository, and I generate the Kubernetes config needed to deploy my computer vision AI app. And at that point, Tanzu Application Platform is finished doing what it does. If it's a successful run through all that, it gets through all the gates, including the CV vulnerabilities, it's going to commit back to an ops repo that Kubernetes config necessary to deploy my app to Kubernetes. So that results back in my GitOps repo under a specific branch. In there, I can find the artifacts that are delivered by Tanzu Application Platform. It's basically a delivery.yaml, which you'll find familiar pieces, deployment and services and things like that. But I didn't have to write this YAML. That's the great thing about Tanzu Application Platform. Okay, so what happens after that gets delivered? Well, you can see that I want to manage my clusters as sets of clusters. I don't want to roll this out to my thousands of stores all at once. I want to be very careful and roll this out in sets. So what I'm going to do as a human, when I'm ready to approve what's been built and I'm happy with my model, I'll promote the latest change up to a specific grouping in a branch inside of a GitHub. There's different ways you can approach this. I chose to use branches for how I trigger certain clusters to update themselves. Okay, so I have that all set up, but what about the edge cluster itself? So back on my diagram, I have a part 1B that I started with as well. First, I want to onboard and manage these small Intel NUC devices or other form factor devices similar in untrusted networks that might be all over the world. And how do I onboard those things? Well, with a new product from VMware called VMware Device Edge, we onboard those devices and then we enable them to have Kubernetes deployed with my app registered for the GitOps mechanism to pull the app and deploy it. Once my cluster is up and running, that will interact with another component within our product family here called Tanzu Mission Control. I'll zoom back out so we can see this flow. Once I have my cluster built, it's going to trigger a flow that I manage through a component called Tanzu Mission Control. The flow is the GitOps flow. Basically, it deploys Flux CD out to the Kubernetes cluster. It registers my GitOps repo, and then it starts pushing those updates down to the edge clusters that I've grouped. And the other interesting thing to point out is that the way you manage your clusters in Tanzu Mission Control, if I get prompted to authenticate again, okay, let me get back into my view here. Wait for it. Okay, and Tanzu Mission Control back in. Tanzu Mission Control has this concept of cluster groups. So remember, I had a branch in my GitHub repo, prod region 1. Now I'm also managing my Kubernetes clusters with the same nomenclature as groups in Tanzu Mission Control. So this small device behind me is registered under the prod region 1, and then you can see that I've registered the continuous delivery flow using GitOps, and this GitOps is referring to a repo pointing to that specific branch. So prod region 1 group of clusters are set up with GitOps focused on any changes that are made to the prod region 1 branch in my GitOps repo. So once that all happens, then I have my application running and deployed, and inferencing results are generated and streamed out via RabbitMQ. So I'm using RabbitMQ, a very small instance of it, running on the device. Anytime this captures any inferencing results from the camera, it publishes those results onto RabbitMQ stream. And then using another component within Rabbit called Shovel, I WAN replicate that off this single node device, which could be stolen or have storage corruption at any point. So I want to get all the data off, all the important data off that device as quickly as possible and send it to cloud. So in this way, I can iterate as a developer, building my Python code using Tanzu app platform to automate the entire process of building my web application, or I'm sorry, my inferencing application. Chose the wrong one there. And so as a developer, I don't need to worry about the complexity of provisioning the edge cluster on small devices at thousands of locations. I also don't need to worry about the underlying tech that's needed to wrap a Python application in a container and do inferencing using the OpenVINO framework. So this is a very brief, quick run through. Obviously, there's lots of details I can share about each and every one of these pieces, but the main idea is to show you that VMware has the entire end-to-end flow of how you can do this with your retail locations. So now I'm going to switch back to a couple of slides, go back to slides, and just finish this out before I hand over to Greg. So moving this out of the way, go next. All right, that was the flow I walked you through. End results, inferencing getting pumped out from RabbitMQ. And so the stack underneath this from VMware that we have to offer, it's called the Edge Services Platform. And what I was demonstrating to you specifically is what we call Device Edge. Any non-vSphere, small single device potentially non-x86 in some cases, industrial devices, fanless. You picture IoT gateways. That's what I basically walked you through in terms of the solution. Enterprise edge is that broader, bigger stack that some retail locations might have. They would have vSphere running on there, running VMs and containers. That's what we refer to as enterprise edge. But as you can see, our edge portfolio spans networking, native apps, platform, and compute, and we have this all packaged up in one seamless place. And the device edge component, this is a call to action for anybody out there working with retailers who have very small devices, single node devices, and you want to make a way to manage your application workloads, manage the security of those embedded, smaller devices, making sure the storage is encrypted, make sure it's secure in untrusted networks, manage Kubernetes and applications that get deployed to thousands of sites. This VMware device edge is in beta, and anybody who's interested, please let us know at the end of the session, and we'll follow up and talk to you about the device edge beta that we're doing right now. I think that's it for me at this point. Hand off to Greg. Greg's going to show you what to do once all that interesting data is sent from the retail locations. What can you do with it? So he's kind of like the next step in the phase here. All right, Greg, take it from here.
Hey, thank you for that, Michael. All right, as Michael mentioned, I'm going to walk through this use case of building a real-time loyalty rewards program. And based on our research, as Howard outlined, most customers want their rewards to be automated based on the location that they are at, but also based on their buying history. So, for example, I love peanut butter and jelly. I also like popcorn. But I don't necessarily like potato chips. So really tailoring the promotions in real time based on what the customer actually likes, and also could be sensitive to their particular location. But when you are building any sort of customer-facing application, really the key to having a good experience for the users is providing the information with little latency. Latency means delays. So every application, a well-designed application, is stateless. So you want to designate the management of the data, like my buying history or even my promotions, to some sort of data store. Now, in order to manage data or to deliver data quickly, you should use some sort of in-memory data store, because memory access is a lot faster than disk-based access. But think about, especially for the online experience, you want to be able to scale up your applications to handle more and more users, but you also want that same convenience in your data store. So you can scale up your number of data store instances to handle more microservices, more applications, but also you should be able to spread that data across multiple different servers so that it can grow to handle more and more data sets. Now, many of these data solutions are often referred to as a cache, and meaning that they can store the most frequently used data. So imagine every promotion maybe has an expiration date. So you can expire historical records all within the data store itself. But you can also respond in real time to updates, change data capture events, especially when you're using some of our products that we highlighted during the previous calls, like Gemfire, where as soon as the promotion is saved in Gemfire, you can trigger a piece of code to alert the user in real time. And solutions like Gemfire allow you to store your data in a format that's native to how it's actually consumed. This is different from relational databases where you have to store the data in a tabular format. You can store that data in nested structures. So again, it sort of improves the speed to deliver this data, so you can keep smiling and dancing users, as the illustration shows. But you may be wondering, okay, what's the best way to populate my low latency data store? Now, I like to use a pattern where I have specific applications that have a focus area or concern. So you can have, for example, a sync app. Now, this sync app is responsible for storing that data into your low latency data store into Gemfire. And a lot of these applications that are really geared towards data movement, they are part of a category of applications which are sometimes called connectors. And you can also imagine that the source of this data, right, providing the correct promotion targeted to a particular user, it's probably derived from many different data sources. So in this case, the sync app may not have all of the details or the data to really drive a correct promotion. So the pattern that it uses is, hey, whoever's going to figure this out, when you're done, just send that data over an event streaming solution for me to pick up and store and make that available to the application. So, and the event streaming broker, like RabbitMQ, as Michael was highlighting, it really supports a really good abstraction layer for your applications that deals with various types of data, and it can provide really high throughput in the order of magnitude of millions of messages or events per second. So even if your applications or your database or your data store can't really handle those higher throughputs, you can use solutions like RabbitMQ as a buffering layer. So you can accept or consume the data at these really high, or ingest the data at these really high throughputs, but you can consume them at whatever rate that the applications or the data stores can handle. But also it abstracts where this data is actually generated from. So whether it's at the edge or at a cloud or across multiple clouds, again, you can use the power of the event streaming solution to move that data around based on configuration rules versus having to always have develop a custom application to move that data around as needed. So this slide really speaks to how I would derive those insights, those customer favorites, and those promotions based on analytics. So you can have, for example, a source-based application that, again, it knows how to, it provides an adapter or a gateway interface to accept various data sources, like collecting the output of the computer vision information, as Michael showed, but also combining that with point of sales transactions and the official source of all of the possible products that a customer can purchase within some sort of enterprise product catalog. You send all of that information, or all of that information can be sent to an event streaming solution. And in this particular architecture, you could have an analytical-based app or a series of analytical-based apps that not only store all of this data into an aggregated analytical database, but also can respond to events, customer-based events in real time to calculate these promotions and favorites. And we highlighted this during one of our previous talks in this series on the benefits of using an analytical database. So for example, determining the customer favorites can really be simplified. The implementation can be simplified by just using a SQL-based statement as shown on screen. So why would I, as a developer, reinvent the wheel and develop this in another programming language like Python and R? I could just utilize the power of SQL and utilize the database itself. But especially when I'm utilizing a MPP or massively parallel based database like Greenplum, if all of this data, you can imagine this can be a significant amount of data for thousands of users or even millions of customers, aggregating all of the information for one store or multiple stores, right? If all of that data can't fit in a single server, No problem. I'll just spread that data across multiple servers and use the MPP-based database to perform my query just as it was one single database. And in that way, I can really manage all of the historical data in the order of magnitude of terabytes, hundreds of terabytes, even petabytes of data. And there is a phrase that says, the journey of 1,000 miles starts with one step. So many of you that are on your cloud modernization journey, you might start out with your solution on one cloud. But we're really privileged to talk to many different customers, and most of the customers, in fact, 73% of enterprises are using more than one cloud. Now, they use specific clouds for specific workloads. So, for example, in this example, you can use all of the real-time transactional views. The web-based application can be in cloud A, but the driving of the analytics can be in a total separate cloud where you have your MPP-based database and your analytical-based app. And then, especially when you're using something like event streaming, again, you can intelligently decide which subset of data is moved from one cloud to another. Now, you definitely need to be careful about moving data out of one cloud into another because there is a cost associated with it. But again, utilizing the power of an event streaming solutions like RabbitMQ, again, you have the intelligence to decide which subset of data you want to move across the clouds. But also, when you're using something like RabbitMQ Streams, it has built-in components to have compression. So you can reduce that payload size to ultimately reduce the cost, the networking cost to move that data around. And whatever your flavor, your favorite cloud-based platform is, right? You can have an abstraction layer like Kubernetes. So again, you don't necessarily need to be tied to one cloud, right? This also provides you as a customer with leverage. If you wanted to move from one cloud to another, or you wanted to negotiate a lower price because you're not necessarily tied tightly coupled to one cloud, utilize an abstraction layer like Kubernetes, which greatly improves those day one and those day two operations, right? Day one, meaning I want to simplify how I'm provisioning my applications, my data services, and even my event streaming solutions like RabbitMQ. But also it maintains a desired state, a declarative state. So for example, this is a text-based file which I provide to the infrastructure that says, hey, provide me with a 3-server instance, a 3-server cluster instance of RabbitMQ, right? That has a load balancer, and I can specify how many cores I want, how much memory I want for each one of those sort of server instances. And I can also provide the features that I want to expose within RabbitMQ. Now, I must admit that I have fun building demos for these webinars. But I will also say that it would not be as much fun. I think I mentioned this last time. If I had to provision 3 separate servers, if I had to install the operating system, install all of the dependencies that RabbitMQ needs, configure RabbitMQ, establish the network connection between the 3 servers and securing the network connections, right? It's just not as much fun as just having this file and say, hey, infrastructure, provide me the output. And then within a couple of seconds or a minute, I have my cluster. Now, I have a quick slide. So this slide really paints the picture of the demo that I'm going to show you, where I'm deploying the solution across multiple clouds. I have an on-premise based cloud where I have my application, my web-based application, and it's using Gemfire as the low latency data store. I have my sync-based application that is receiving messages from RabbitMQ, but all of the analytics is calculated in a totally separate cloud, in a public-based cloud. And that's where I have my MPP database, Greenplum, I have RabbitMQ, and I have my source-based application that is exposing HTTP-based interfaces that will aggregate information like point of sale transactions and the product catalog information to be stored in the database itself. And all of these applications are using my favorite framework, which is Spring Boot. Shout out to the Spring One talks that's going to be happening in VMware Explorer. I hope that you are able to join us for the conversations there. But let me go ahead and start to share my screen. All right. So here is the application itself, right? That's running in the in one cloud, in the on-premise cloud. And as I mentioned, this data is, I have a view of all of the services in the applications that are stored in the on-premise cloud, right? The real-time online cloud. And here, the prefix where it says GF Redis, that's basically Gemfire. Gemfire has a newer feature where you can have Redis-based applications talk to Gemfire, and it kind of looks like a Redis-based server. And if you're not familiar with Redis, Redis is another open source caching technology that just exposes a different interface. And then also I have RabbitMQ running. I have my sync-based app that is waiting for messages to be sent from RabbitMQ to store into Gemfire. And then I have my web-based applications that's going to pick up those changes and display them to the screen. Now, within the analytical cloud, here is the view of the applications or the services that are running in my analytical cloud. So I have another, again, as I mentioned, I have my source-based application. I have RabbitMQ, and then I have this analytical application that not only stores the data into Greenplum, but also performs those real-time based analytics. And as I mentioned before, Greenplum is running on the cloud, but it's running outside of Kubernetes. I can access all of the data that's in Greenplum. So, for example, I loaded my product information to Greenplum. And one thing that's a newer feature in RabbitMQ is something called the RabbitMQ Streams. So with RabbitMQ Streams, I'm actually using my product data, because you can imagine that product data is probably going to be needed by many different applications, right? Maybe at the edge, maybe across multiple different sites. So you can use RabbitMQ as a source of truth for this data. So what I did was I deleted the product information from Greenplum doing a truncate command, so that when I select this, right, the data is empty. But the application itself, in this case, this real-time this analytics-based application, what it will do is I actually deleted the instance of the app. And you know what's happening? The infrastructure itself, because remember I mentioned that it maintains a declared state. So the declared state is, hey, I always want at least one instance of this app running. So even when I deleted that app, the infrastructure itself restarts the app. And when it restarts, it's basically rereading or reprocessing the data from RabbitMQ and storing that back into Greenplum. So again, even though I deleted that data from Greenplum, again, it's reloading it from RabbitMQ because that's the source of truth in this particular use case for the product catalog information. So the next part of this demo is really, I'll just walk you through how we actually built these promotions. So what I'm going to do is just move this over to the side. We're going to open up this command line interface. And in here, what I could do is I'll clean out the cache. So we're going to clear out the customer favorites. And essentially what I'm doing is I'm clearing out the Gemfire cache. So when I do that, when I do a refresh, it basically clears out the promotions. It clears out the customer favorites. And what I'll do is I'll walk through what I did. So I would purchase my favorite items, which is peanut butter. Let me do that again. It's peanut butter, jelly, and milk. And with this particular use case, it knows that I always purchase these items together. So in this case, again, this data is being sent to the analytical cloud. It's being processed by the analytical the app, and then it's essentially sending that data from one cloud to another, just using RabbitMQ, right? So it's able to provide this promotion of milk because it knows that I like milk, right? But even with this transaction, I didn't purchase milk, I just purchased peanut butter and jelly. And in this case, I didn't purchase peanut butter. I just purchased milk and jelly, and it provides a promotion for peanut butter, right? So you get the idea. You can also combine this with inventory information. So, for example, maybe there's a specific brand of peanut butter that's not selling, and you have a high availability of that particular brand of peanut butter, right? You can give that recommendation to me because I might appreciate saving a little bit of money and trying a new brand. All right. So, and that's the end of my demo. So I'm going to stop sharing, and we can open it up for questions.
Cool. Thank you, Greg, and Mike, for your demos. I've got a question for you, Mike, around the conversations that you've been having with retailers, and are you seeing a developing trend or an increased interest in using computer vision applications at the edge, either in store or at distribution centers for specific retailers?
Yeah, absolutely. We're working with some pretty large retailers, especially in the grocery business, but there are others that really want to add, kind of like what this picture is showing here, a little bit more smart shopping to the customer's experience. In some places, potentially even doing away with actual people working in checkout lanes and things like that, where folks can go pick up product off the shelf and just walk out the door with the bag, and everything be transacted automatically. And then there's safety, spills in the aisles, being able to see when those sorts of things happen, or maybe traffic up and down aisles and rows in large retail locations to find out which products are doing well. And if somebody picks something up and puts it down, I think the marketing folks want to know when that happens and look into why it's happening. So yeah, it's quite a big focus area for a lot of retailers for many different use cases. Like I said, safety, marketing, consumer behavior, and even store operations efficiencies and things like that.
Cool, thank you. One other question, Greg. How does RabbitMQ streams, how does that, in your experience, how does that compare to solutions like Apache, Pulsar, or Kafka, which are applications that people most obviously associate with streaming from event-driven architectures?
Yes. So, I've been having several conversations with customers about this particular aspect of Rabbit, and I would say historically, especially for the high throughput use cases, because we were talking about millions of messages per second, right? You wouldn't think of considering RabbitMQ for those high-end throughput use cases. Now, with the streaming capabilities of RabbitMQ, now you can start to consider it, right? And it's in the notion of using RabbitMQ as a source of truth, where every event that is sent to Rabbit, when your applications are processing that, those events are they can stay on Rabbit, so that they can be replayed for one particular app, Or another app could say, hey, tell me what you got. Give me all of the latest product information, and I'll store this. It's perfect use case for storing into like a database, right? From one location to another, right? Or think about, you have one retail store, right? You load the data in that retail store. Maybe you're starting up a new store, right? That new store could just reload the latest details from the stream, right? So now all of those capabilities are now included within a RabbitMQ itself. And a lot of our customers were using Rabbit and those what I call event log solutions before, right? And now you can reduce your technical debt or your complexity where you have a single solution that handles like those traditional message broker use cases, in addition to these more higher throughput event log use cases, all from RabbitMQ. And plus, we're adding all of the operational efficiencies on top of that. So, as Michael mentioned, being able to simplify deployments at the edge, deployments at the cloud, deployments on Kubernetes, deployments on VMs, right? Just a simpler model. In addition to, we talked about the various protocols that RabbitMQ supports, right? So it has this new streaming protocol, but also, it still does all the other protocols, right? Like the MQTT, that Internet of Things friendly protocol, where you can take the sensor data and send that right to RabbitMQ, right? You can have the AMQP, which is another protocol, or Stomp or ACDP, right? All of those things, all within a single stack, is really reducing the complexity from a development point of view, but also, most importantly, from an operation management point of view.
Yeah. Thank you, Greg. An interesting comment from the audience has come in about, folks don't like being tracked online, let alone in store when they're doing their grocery shopping, and that's a challenge that, in many respects, society as a whole has got to address, as well as those people that are developing those kind of platforms. And it calls for careful policing of the use of data. And I think the Edge has got a good part to play in that, in the respect that anything that's processed, any images or anything like that are processed, the images are thrown away. It's just the metadata that's persisted. And if that metadata is very specific to the use case, i.e., has the customer picked up peanut butter or jelly, kind of thing, and understanding the performance of the store, hotspots in the store where you're not tracking whether it's a man or a woman in the store, it's a shopper, and it's no more detailed than that. And I think there has to be some careful responsibilities there for sure.
Yeah, I think computer vision is going to drive some new clauses in SOX and GPDR and privacy type frameworks, where auditing is going to have to get smarter about what computer vision is doing and how it's handling the data that it's gathering visually. So
yeah, for sure.
I think definitely a good point, and I'm sure we're going to see more of that from auditors.
Yeah. Cool. Well, I think we're at time, aren't we? I think we've got about 50 seconds left or something.
We do. I do want to just give a special thank you to Gregory, to Howard, to Mike for joining us today, for presenting on this topic for this series. I am noticing a lot of clicks and downloads on some of the assets that we provided, such as overview for VMware Data Solutions and the 2 GitHub links for Tanzu Solutions Engineering and for object detection. If folks had more questions or would like to reach out to you guys directly, what would be the best way to reach out to you guys? Is it through LinkedIn? Is there an email alias that they can reach out to?
Yeah, LinkedIn is probably one of the best. Easy to find us there.
And
great.
And I guess we'll list our LinkedIn links with the recording that gets published on our website. Maybe that's the way we can find. Okay.
Great.
Sure.
Perfect segue there, Michael. I didn't mention this yet, but I'll mention this now. This has been recorded and will be available on demand. And I think we'll be putting this up on YouTube shortly after as well. So feel free to either share the on-demand recording link or the YouTube link once that goes live. So I do want to just say thank you again to our speakers, to most of all to you guys for joining us today. I know this is a third partner series. Maybe we come back for a fourth part. We'll have to see, but we do thank you guys. We do hope to see you guys again and have a great weekend. Bye all.
Thanks,
Thank
everyone.
you.
Bye-bye. Happy Mother's Day to everyone.
Happy Mother's Day.
Happy
Yes,
Mother's
great.
Day.
Bye.